So today we're going to be focusing on creating our packages using RStudio. And I'm going to paste the link to the notes for today that I'm going to be going through. I'm going to be jumping a lot into RStudio, but the notes will kind of guide you through what I'm doing today. Logistics, as usual, please jump into the chat, ask questions. It's kind of hard for me to follow that while I'm lecturing. I try, but that's hard. But this is a group activity. Please just feel welcome to jump in there and answer questions for people. That's kind of your space as for interacting as much as it is for me to see your questions. And then after I present the material, then we'll kind of open it up and you can unmute and I'll stay on usually for like a half hour to answer any questions that you have that come up. And if you missed the previous sessions, that's all up here. Go to the website and I've got links to the video there and all the slides, all the material for you to go through. All right, let's jump right in here. So our packages. So, hearing that, you may think, oh, wow, why would I use an R package? Like, I don't create software for other people. I'm just coding for myself. Or maybe you do create software, or not software, R scripts and R code. Maybe you do create that for other people, maybe people on your team, or maybe, for a larger audience. And maybe right now you're just creating these R scripts that you share with people. So, if you're in that situation, you're thinking, oh, well, why would I create an R package? Well, the R package is going to really help you write more robust code that's going to last longer, even if you're only coding for yourself. If you've ever been in that situation where, you write some code and you come back to it a year, 6 months, 3 months later, and you look at that code and you're like, oh, what was I doing? How does this function work? So that's a situation where an R package can really help you collaborate with and help out your future self, because your future self got confused and you were the one who wrote the code. This happens to me literally all the time. If I don't use an R package and properly document my code. But, imagine how that is if you're sharing your code with somebody else, and it can be really hard for them to figure out, how to use it. And, think about if they want to extend it, that can be really hard too. So the package framework is really, as you'll see today, super, super easy. And it's going to make it really easy for you to document your code and share your code and build on your code as you work in the future. Okay, so here's my longer answer, and this is kind of what I just talked about here. So let's start off and let's just make an R package right here. So here's the instructions. You can see that, and I'm going to do it. You feel welcome to, follow along with me. Just going to open up RStudio. Oh, you can see I was doing some things. I was working on the material for today. So you won't, if you open it up, if you haven't been working on something, you're not going to see anything. But what you want to do, regardless, is you go up here in the corner and you're going to say new project. You're going to say new directory. And there you go. You see the second thing there? It says R package. Great. Let's just click that. Okay, we need to give it a name. I'm just going to call it test package. Hey, get back in there. Okay. We can ignore that. We need to make sure, where we're going to create it. Fine, I'll create it here. This is where I keep all my GitHub repositories. I might make this a GitHub repository later. I will next week, so I'm going to put it here. Create a Git repository. I'm not going to do that right now. Use R-env. No, I'm not going to do that. Open in a new session. Yeah, that sounds like a good idea. So then I do create, All right, that was it. I just created an R package. Simple as that. And this R package, I'm going to go through the elements of this in just a moment, but I'm just going to jump in and show you that we can build our R package and use it. I need to look here in this R folder. I see it's got this function called hello, so I need to know that. So now that this is an R package, Git RStudio recognizes that it's an R package because it sees this description file right here. And once that happens in RStudio, we have this little tab that's called the Build tab, and we can click this button, which is Install and Restart. Boom. It builds it. You can see now in the console, it's saying library test package. So it's loaded up our package. And I looked and I saw that there was a function called hello. Let's do question mark hello, find out how to use that. Okay, print hello world. Okay, that's great. Usage, hello parentheses. Okay, great. So now I hope you can imagine now how like you're in a situation and you're creating some code and now you're coming back a year later and you've totally forgotten how any of your functions work, but you were smart and you wrote a little bit of documentation about how to use your things. So when you come back to it 6 months later, you just had to do question mark function and your past self told you what to do. So my past self told me, well, this is actually the RStudio makers who did this framework here. They created hello, but they tell me how to use it. So I just do hello. There we go. And it works. Hello world. Because I've installed this package, I have access to the functions in this package. Okay, let's hop back over here. Okay, so that just shows you how easy it is to create a little package template. And we're going to add to this package, add some functions to this. But as you can see, super easy. All of you, if you have RStudio installed, will be able to follow the steps I just did and create your own little toy package immediately. So now let's go through the key parts of an R package. So there are really only three things that you absolutely need in an R package, and that's this description file, and it has that name just like it's written there in all caps. And it's not description.txt, it's description, that's it, no file ending or anything. A file called namespace, written just like that, and an R directory that's going to have your functions. Let's take a look at that here. Let's see what it looks like. Okay, so I go over to my files. Let's start with the description file here. So this is the basic format of this. When you're starting, you can just stick with this more or less. We're going to have to add a few things when we start adding package dependencies. So that means that your functions use other R packages. And I'll show you that in just a moment. But just for the basics, if we don't have any packages, other packages that we're using in our little test package, looks like this. We need to give it a name and type, title, version, author, maintainer, and then we tell it the description, license, it's going to work fine without the license specified, but generally we would say something about the license of a package. Don't really sweat that. Sometimes beginners get a little hung up, like, what should the license be? Okay, don't worry about it. You can see our package worked just fine. And all it said here is, what license is it under? And clearly it doesn't have a license, but it works just fine. The package works fine. Encoding, generally you don't have to worry about that. The lazy data equals true. I'm going to cover that in just a moment. that's not really critical. You could leave that out and it would work fine. Okay, so that's just the basics that we need in our description file. In terms of remembering all these things, well, you don't remember them. You just use, you generate a package just like I did, or you look at a package that you wrote before and you copy it and then you edit it. Okay, so that's the first thing. That's pretty simple. And the next one is this thing called the namespace. And if you generate your package, your toy package, like I did using RStudio, it's going to create this namespace for you. And it has this funny looking function right there. You can tell it's a function because it has like a name and then it has the parentheses here. And this particular function is saying export all the functions within this R folder. You wouldn't be able to guess that unless I told you that, but that is what it's actually doing. We're not going to use this. We're going to export our functions a different way. So what does it mean when I say export a function? So you, when you create functions in this R folder, so like this, here's my hello. This is, it's got a little commenting on the front there, but then it has this function, and this is the name, hello. You can see a function, and then it does something. And you saw here when I called it, it just printed hello world. So this is a function. And when I say you export the function, all that means is that when I load this package, I can type hello world and something happens. If I didn't export that, so make that visible to the user who's loading the package, if they typed hello, nothing would happen. It would say, I don't know what that is, because we didn't make that visible. So when we write packages, we make explicit decisions about the things that the user will see, what functions they will see, and what functions they don't see. And in when you make this little toy package using RStudio, what it's saying is make all your functions visible. Okay, so the next thing that we have to have is we have to have some code. So here, that's going to be in this R folder, and you create these files with your functions. So you have a series of functions, and then those functions are the user can use those functions, and your own functions can use your functions. Okay, great. So pretty simple. That's really it. Now, in practice, we're going to have a couple basic add-ons. So Diana, should each function have its own script in that folder? Yes, absolutely. Each function should have its own file. And it's traditional that you will name the file by the function name. You don't have to do this. You could call it anything, but it would be very hard to find the files associated with your functions if you didn't name your functions. Sorry, name your files by the function name. But for example, sometimes like if you have, say you had a lot of different, let's say, let's say you had a different plot functions, a lot of plot functions, and you might decide, oh, I want these kind of organized to make it easier for me to find them. So you could call the file, plot hyphen and then the name of the function. You might do something like that. Okay. Get back here. Okay. So basic add-ons. So the man directory is what's going to have the documentation. We're going to use a package called roxygen2 to write our documentation. And that's the standard. and you should use it. Okay, everyone uses that. We don't like manually write our man files anymore. That would be a highly inefficient way to work. So I'm going to be showing you how to write your function documentation using the R-Oxygen 2 framework. Another basic add-on is data. So if you want to provide data to your users, you'll have a directory called data, and in there you're going to have files that are in the RData format. So like with the ending .rdata or .R data. Okay, so I'm not going to talk about the other add-ons, but they're kind of listed here, other things that you could use. I want to now I'll answer some questions, and then we're going to jump into adding some more functions to our package. Okay, so question from Lisa, can you explain the advantage of a package over a project? So you notice here, I am in a project here. I'm in the test package project. You can see that by up here, test package. And if you look in my files, you see the R+Proj. So I am in a project here, but I am using the package format for a number of advantages. One, it's going to make it super easy for me to document my functions. It's going to make it super easy for me to share my package with other people. So share my code with other people. It'll make it super easy for them to understand my code and understand my functions. And I can, as you'll see next week, there's a lot of cool, super easy ways that you can share your R package on say, GitHub, either privately or publicly. Or you can, create a zip file and you could email that to someone. But creating it as a package, making it easy to share, you can also start versioning your data so you don't get lost in what version of your code that people are using or that you yourself are using. Okay. Yeah, so Peter asked, if you have many functions in a .r file, which ones will be exported? So, yeah, they will, it depends on how you write your namespace file. If you were to write it like this, it's going to export all the functions. If you are using R-Oxygen, which you should, then I'm not sure if you can have multiple R-Oxygen headers. That's not the style that people use. They don't have multiple functions in their .r files, except in certain types of situations where you have like a main function and then you have various sub-functions. And that's a context where your documentation that you'll have at the beginning of your .r file, and I'm going to show you how that works in a moment, you would document those sub-functions in that R-Oxygen header also. So in that case, you are exporting multiple functions. I'll show you how you export your functions. You'll see it's quite easy. Yeah, exactly. Thanks, Ariana. Yep, and Ariana just sort of echoed what I just said. Yes, group, very, very related small functions. Yes. Yeah. So like for a good example for me is like I may have I do I'm creating objects in my packages. I specify objects, and then I'll have certain helper files that are associated, or that files that are functions that are related to these objects and certain things that these objects can do. Okay, but that's a bit more advanced. I think, as I and Ariana noted, in good practice is generally to have separate files for all your R functions. Okay, so let's jump in and actually make this more realistic and add some functions and start adding some package dependencies. So our functions are going to use other packages. So first, I mentioned our Oxygen 2. So we're going to start using that. And we need to set things up to use that. Now, I put the code here, which is using a package called use this. Once you start creating a lot of packages, we often use this package called use this. It's really handy. I'm not covering it today because I want you to understand the fundamentals. And I think when you're starting, you might get a little confused by use this and all the things that it's doing. So I'm starting a bit simpler, but just be aware that if you're already pretty familiar with packages, then learning the use this package will help you out a little bit. Some of the things I'm showing right now will be automated by the use this package. So in particular, the steps I'm going to show in adding our Oxygen 2 are going to be automated. Okay, so first what we want to do is we need to install the R Oxygen 2 package if you haven't already. That's the code right there. I'm not going to run it because I have it installed. The second step is we need to delete that namespace file because our Oxygen 2 is going to create that. But it's nice. It's not going to destroy an existing namespace file. So our Oxygen 2 is not a destructive thing. So we need to get rid of it for it so it can create a new one. So I'm going to delete that. There we go. Yes. Okay. Got rid of that. Okay. So that's first thing we need to do. Then we need to set our project options to use our Oxygen to create our documentation. So let's do that. So I'm going to go here and I'm in RStudio, going to click Tools and going to do Project Options, going to do Build Tools, and here we go. And now you see we have this checkbox, Generate Documentation with our Oxygen. If you do this and you don't see this, what's going on is you haven't installed the R Oxygen 2 package yet. So if you haven't done that, go back and install our Oxygen 2. So we're going to click that. That's nice. Okay, so let's look here. I'm not going to talk about vignettes today, so we can leave that unchecked. But we do want to make sure we check this. So what this is doing is it's going to recreate our documentation every time we click install and restart. I showed you that right in the beginning where I showed you the build tab and I did install and restart. So that's what that's talking about there. So we want to rebuild everything when we install and restart. So we just say okay. All the rest of this you can just ignore for now. There we go. Okay, great. So we've done the 2 steps we need to do. We deleted that and we set up the project options. Now we are ready to go. So let's go in and we want to update our hello.r function. So I'm going to copy this right here. And I'm going to go back here. I'm going to open, here it is. Here's my hello.r function. And I want to get rid of what's there. And I want to put this in here. Okay. So now it's a little bit different. And you notice, why is that up there? I don't want that. Okay. So you notice that we now have this header that is a hashtag and a little check mark there. Okay. That is an R Oxygen header. And our Oxygen 2 is going to use this information to create our documentation. And right now, it's really simple. We just have a title. You notice it says @ title. and then @description. There's our description. And then notice it says @export. So it is telling it to export this function. Now we are making an explicit command to export a function. If we did not export this, the user would not be able to type hello, parentheses, parentheses, and have it do anything. So let's go ahead and save that. And now we're going to do install and restart. Oh, dear me. Oh, goodness gracious. Okay. Please don't tell me this is going to not work. Starting. Okay. Now I have to debug on the fly. How unfortunate. Sorry, just going to take a moment. Don't know why. Yes. Delete that. Install rlang. No. Okay, let's try now. Okay. Whew, that was lucky. Okay. Great. Thanks, Ariana, about the multiple R-oxygen headers. Comment. Okay, so now let's see what's happened. Okay, so I did something. Let's go back up here in this tab and see if we can watch what has happened. Okay, so first time using our oxygen, upgrading. Okay, that's fine. Writing. Oh, warning, skipping hello RD. Well, I don't like that. This, I warned you, like it doesn't, our oxygen 2 is not destructive. So it saw this hello RD. And what is it talking about? It's in this man folder, this hello RD. It's warning us, hey, I didn't create this. I'm not going to destroy it, but I'm going to warn you about it. So I want to delete that. Let's do that. And let's install and restart again. Okay, now let's go up here, see what we're doing. Ah, much better. Okay. Updating the documentation. That's what I wanted it to do. And it's writing the hello RD. Excellent. Okay, let's go take a look at this and see what it wrote. So you can see it generated it. Yay, that's great, because you can imagine this syntax is really a pain to remember. You don't want to remember that. Just let our Oxygen 2 create it. Basically, it just did some name stuff, and it created this usage here. So let's do our question mark and let's see what it looks like. And there we go. You can see now we have this really simple documentation here. And it was created by the information we specified in this header here. Let's see if I can add. I'm going to add an example. Hello. Let's do that. See what happens. Okay. Did I do something wrong? Did something wrong? What did I do wrong? I don't see hello.rd in the files window. Click on the man folder. Okay, great. Okay, I just misspelled that. It's supposed to be examples. And so this shows you how I can give an example of how to use this function. And, this is a really simple example here, but imagine if your function were a bit more complicated and you wanted to give a use case example, and it's right there in this header that you wrote for your function, and then it shows up right down here. So you can give some little bit of code that shows your user exactly how to use your function. Your user, which is someone you're sharing it with, or your future self. This is going to be really helpful for you. And notice a key feature about this is that this documentation is right in there with our function. We don't have two separate files. So it's much, much easier to keep your documentation updated with your function file. Okay. And let's go back over and see what our Oxygen 2 did with the namespace. So now it tells us that it generated it. We know that we should not edit this ourselves. It warns us not to. So don't edit it yourself. Let our Oxygen 2 edit for you. And it created this thing that says export hello. So it's saying export that hello function. All right. Let's go in and let's add some data to our package. So now we'd like to have some data that when we share this package, the user is going to have some data available. And there's lots of different reasons you might share data. First off, it may be data that you're trying to get out there, or it may be data that you want to have like test data, so the user can just run your functions with some test data. So what we're going to do is we're going to create some data, and there's a data file. It's a data frame that's within base R that's www usage. So I can just do, this is just in base R. I don't have to install it or anything. It just comes along. And it's actually a time series. And what we're going to do is we're going to take that time series, we're going to square it, and we're going to save it in a file called www2.rdata. So this is important. It needs to be an RData file. I'm going to do this. And go back here. Okay, so we need to create this folder called data. It's important. Let's do that. So we've got that folder called data, and now I'm going to paste that code in here. So I'm creating this object called www2, and I'm going to save that object www2 into this file. So there we go. And now if we click there, we see it's now in data. And now let's remove www2. Okay. So I remove that. Now if I do www2, it says, I don't know what you're talking about. I don't have it. Let's install our package. So we've added this data, but we haven't like rebuilt the package, right? So the package doesn't know about the data yet. We're going to have to rebuild it. So we just did that. We rebuilt it. And now it's got that data in there. And now when I said library test package, so I load the package and I do www2, there it is. And it came from the package. It's not like in my environment or anything. It's in the package. Okay, so that's how we could include data in our package. Any questions about the stuff so far? I'm now going to go into how to create functions that depend on other packages. Yes, you can most definitely do a help file with the data. That's a really good thing to do. So if you scroll down here, you can see how we could document the data. And here I give an example. But let me just copy that, and we're going to make a little help file for that ww2. So I'm going to copy this because that's the format I want to use. I'm just going to edit this. Let's go back here. Let's see the instructions here. So it says, first I need to add something in the R folder. Okay, that's going to be a little non-intuitive, but all the documentation is coming from things in the R folder. That's where our Oxygen 2 is looking. So that's a little non-intuitive because we're documenting data, but we do need to create the file in the R folder. And you can name the file whatever you want. I personally always put data hyphen on my data, and that way I know immediately that this isn't the, in this case, Setosa function. It's actually, I'm documenting data. So I'm going to do that here. So I'm going to go here. I'm going to go in R. So I'm now in the R folder here. I'm going to create a new R script. I know that seems funny, but that's what our Oxygen 2 is going to look for. I'm not going to define a function. You'll see here, it's just going to have some R Oxygen 2 header code. So you know it's an R Oxygen 2 header because it's got the hyphen there. And the title, description, well, I don't need itemized, so let's get rid of that. Description is just the WW usage data set squared. There we go. Doc type, yeah, I do need that. The name, I do need to tell it the name. That's important here. 2, usage. So there we go. References, it's in the R base package. It's a data frame. No, it's not a data frame. It's a TS object. It's a time series object. Keywords, don't need that, but I always use keywords when I do data sets. It's going to come in useful later, so it's just kind of a good habit to get into. And that's it. So now I need to save it. So let's make sure we're in the R folder. And as I said, I'm going to name it data hyphen, just so I can find it. You can name it whatever you want. So, and it's got to be .r. There we go, save. So now I have documented my data. I will note one thing here, and that's that I have this @name thing. It is possible also to get rid of that and do it like, ooh, hey, don't do that. Do it like this. That is also an option. I think in the Hadley's R package manual, you'll see it done like this. I don't do it that like that. No, where should it go? I have to give my name at name. Make a mistake here. The reason I'm not doing it that way is that the way that they do it in the R package book, if you don't use lazy load equals true, then the way that they show you is going to fail. So I do it in this alternate way, just because sometimes the students, so for you, if you left off that lazy load thing, all of a sudden your documentation would break and it would not be very clear to you why it's breaking. So this is robust to that lazy load command in the description file. So if I do this and I do install and restart, great. And now when I go up here, you see it wrote this documentation file. And if I go here under man, I see I now have that file. And there we go. And it's written this for me. If I do $WW2, now I have the data set documented. I find this feature, being able to really easily document my data sets, incredibly powerful. Like, invariably, I will forget exactly how I created a data set. So I always keep, like, whenever I create data or update data, I update my data documentation. And then, 3 months later, when I'm coming back, I don't have any questions about where that data came from and what the references are. And I don't have like the information about where the data came from sort of scattered around in different places. Okay. Super, super, super. Okay, great. So let's move on here. And now I need to show you guys how you can use other packages in your functions. So let's go back up here. Okay. So now we're going to add a little more realistic functions. So obviously, our programmers were using other R functions constantly. So let's add a little function here, and this is going to use the forecast package, and it's going to use the ggplot2 package. And here's our little forecast. It's just going to take some data, string of data, and it's going to fit a time series model to that. This happens to be a REMA model. And then we're going to create a little forecast for however many years we specify in this function, and then we're going to plot it. So let's copy this. Go back here, and we're going to say our script. Oh, wait, I didn't want to do that. Sorry. Oh, yeah, our script. That's right. Okay. So I'm going to do that, paste that in there. I'm going to save it. Need to save it in the R folder. Good. I'm going to give it the name of my function, little forecast.r. Okay. So now let's go and take a look at this our oxygen 2 header, because we've got a few extra things to it. So here's the beginning. You notice this time I left off that at title. When I showed you that in the beginning, I had at title there. I did that because I wanted you to see exactly what each line is referring to. I could put at title here like that. Oops. At title. I could do that. It's going to work great. But just as a shortcut, our oxygen 2 will assume that the first line is the title. So people often leave that off. And then they have a line return, and the next bit is considered the description. So you don't actually have to have the at description, but if it helps you remember what these different parts are, by all means, use the at title and at description. So now we've got a couple new things, or yeah, we've got the at param. So what that is it is defining what these arguments that we're passing into our function are. So I say, here's what it is. It's a vector, a time series of data. I could put as much information as I wanted here. And this, again, is super powerful to your users and your future self to remind you what exactly that input needs to look like. So I specify all of them. This at return says what it does. It returns a plot, that's all. I add some examples of how to use this, so I don't have to guess how to use this function. Show some code. And I have the at export, so that means make this available to the user. Okay, great. So let's, well, I could, let's see what happens if I do this. See if it's going to warn me. No, oh, didn't warn me. Okay, great. So, so built just fine, made the documentation file. I can do little forecast. Great, so it's got that there. It has my examples. Excellent. I can just, copy this. I got all of it. In 10. Okay. And it made the plot there. Okay, so do you notice I hesitated a little bit? I said, oh, I wonder if it's going to warn me. So you notice this worked, but what if I hadn't had the forecast package and ggplot2 installed? I have them installed because I use them all the time, but many of you probably don't have the forecast package installed. And if I shared this with you, it would just, the function would just break. It would say, hey, I don't have the forecast package. So you would like your package to recognize that it needs the forecast package and that it needs ggplot2. So here's how you can see which packages are used in the function. I've got forecast : : so that means this function AutoArima is coming from the forecast package. This sort of convention here of specifying the package that a function comes from. So this is a habit you need to get into if you're developing packages, because the package will require it. Like if you want to pass your checks, and it will require that you specify it. I'll also note that it's going to be way easier for people who look at your code to understand your code if you use this convention of specifying the package a function comes from. There's no like wondering, hey, what did this come from? Like, I have no idea what package that came from. You tell it came from forecast. All right, so how do we specify that our package depends on forecast? So now we're going to edit our description file, is how we do that. And you may have seen this before. Oops, let me go here into, okay, here's our description. And we're going to add this little thing here, which is imports. That's all I really need to do here. Okay, here's my description. And I'm going to add imports. There are two lines in our description file that tell it what packages we need, two common ones. They are depends and imports. There's some other ones we could use, but I'm just going to focus on these. These are the crucial ones. Depends will make the package available as soon as the user says library your package. So if I were to say here depends forecast and ggplot2, when I say library test package, it's also going to make all the functions in forecast and ggplot2 available to the user. And you might think, well, that sounds great. Wouldn't we always want to do that? No, because you don't know what the user's doing. Maybe they have another function that's called AutoArima, and they're not really going to thank you for suddenly installing the forecast functions on top of whatever they have installed. So it's a little mean to do that if you don't need to. Secondly, you know, it can happen that you have tons and tons of package dependencies. And imagine, like, somebody emailed me the other day and they had a package that has 100, it depends on 160 R packages. Wow, if you imagine installing that and you're making all of those functions visible to the user, I mean, you could definitely cause problems. They're really easy to create some conflicts. So you don't want to make packages that your package depends on visible to the user unless you need to. So in this case, I don't need them to see forecast and ggplot. So I'm just going to say imports. Now, why do I do this? Why do I say imports? Because when somebody installs this, it's going to say, hey, it depends on this. I'm going to install this for you. You've all seen this when you have installed packages, and that is how we're doing this. So let's save that, install and restart. Okay. Great. Okay, so let me, okay, I've got about 5 more minutes here. Let's look. Okay, we'll go back and take a look at that namespace over here. Is anything changed? Okay, we've got our hello, we've got our little forecast. Excellent, excellent. Let me just change this to depends, and I'm gonna see something that's gonna change here. Don't do that. Okay. So never mind. Keep that as suggest. All right. So let's go and look at another example function. I want to show you something that if you use tidyverse, you're going to use a lot of piping. And in the piping example, we need to export a function from another package. So we need this to be available to back up. When we're using a pipe from tidyverse, it's actually from the mgritter package. We need to import that pipe. I'm going to show you how to do this because this is a super common thing for people to need to do. And if you haven't seen it before, it can be really hard to guess how to do it. So I'm going to take this one, and it's using dplyr. Going to create our R script. So just as before. Averages.r. Okay. And now you can see this is the title, this is the description, this is the only parameter, and I'm saying export this. It's using this function in the R database, not David, the R data iris. It's just something that comes with base R. And you notice here that it's using this pipe here, and it's using dplyr. And I've specified every function that's coming from dplyr. So now I need to go into description, and I need to add dplyr here. Okay, so I've done that. So I want to make sure I keep track of my. Whoa, why did you do that? Sorry. Should be imports. Okay, so I import forecast, ggplot2, and dplyr. So you notice I had suggest there. I must have typed that by accident. Suggest would be something that you use in like your vignettes or your examples. Your package doesn't depend on it. Imports, it really does depend on it. It's not going to work without it. But you'll notice that in this, I have this pipe here, and it's not going to work unless I import that pipe. And this is how you do it. You're going to add a file into your R file with the command import from mgritter pipe. So this may seem like it's going into the weeds here, but I show this because in my experience, these pipes are used a lot by people, and it is, like I said, super non-intuitive what to do about it. So go back here. I tell you how you create something called import packages. Going to do here R script. And it's just, you just need to get this command, import from this package, the pipe is actually a function. So that's what's going on. You just need to create that. And you could have lots of imports in here. So this is how, if you needed to import something else explicitly, that's how you're going to do it. Okay, I think that, yeah, I've gotten through all the base material, went a little bit into the weeds there with the piping. One bit of a recommendation, if you do end up doing a lot of R packaging and you use these pipes, if you use the base R pipe, which I put a link here to it. up here. Yep. Right here, it's this thing that was introduced in a recent version of R. So people are switching to that so they don't have to be have this headache of this pipe. Okay, great. Yes, thank you, Jennifer, about the comment in the base R. Yeah. So this, for those of you who use pipes a lot and it's already in your code, it does take a bit of work to transition over to the native R pipe. Read up on it. There are a few differences to be aware of, but I think that in the long run, it's really going to pay off because then you don't have this dependency on these other packages. Okie doke. Okay, so I'm going to stop there. Next week, I'm going to show you how you can share your package once you create it. Review the different ways, and then I'm going to show you how you can share it on GitHub, which is a super nice way. It's a really nice, easy way for people to install your packages. I'll show you how you can create a super nifty package landing page in basically one line of code. And then I'll introduce you to some basic GitHub actions. So GitHub actions are going to be ways that you can edit your package, and then it will automatically check it and remake your landing page. And it's easier than you might imagine. Okay, great. So let's hop on here. And I'm going to start answering questions, and you can also unmute. Okay. Yes. Are these recorded? Definitely. Yes. If you go to the workshop website, I have all the lecture video on here. Usually takes me a couple days to get that. I'll put that up. Is there a common keystroke shortcut for that pipe like there is in dplyr? Logan, somebody else would have to answer that. Does anyone know? If you know, go ahead and put that in the chat. Would you recommend putting the dependency in packages? Putting the dependency in packages for now, in case people are running an older version of R. So, Diana, I'm going to guess that you are indicating the dependency on the version of the package. And so if you go here, so you can put the version next to it. And what is the format of that? I have to look at that myself. I do it all the time, but I don't have it like totally memorized. Well, where are you? Right here. Okay. Okay. Yeah. Okay. No. Oh, goodness gracious. Okay, well, here's one example. Most of them I didn't have it. So here's an example where this is a description file of one of my packages, and you can see I have a dependency on this particular package that I'm saying it has to be greater than or equal to this version. So it'll check that, and if the user doesn't have this recent version of KFAS, it will complain, and they have to install an earlier version. But you'll notice that most of the things, it doesn't really particularly depend. I just want them to have these packages.
Thank you, Eli. Sorry, this is Diana. I didn't stop you because that was helpful also to know about the versioning, but I typed that during the conversation about inserting the dplyr and migrator so that
Okay.
So I was just wondering about, like, for now, even though there's now a native pipe, would you recommend putting that into our packages just so that, because anybody running an older version of R wouldn't necessarily have a native pipe?
So, yeah, so that's something you want to think about, right? Like how common do you want to force your user to upgrade R? So you notice here that I have said this depends on this version of R. And you could say, hey, it depends on R greater than 4.1. If you're using the new pipe, then you would want to do that so that the user is alerted that they need to upgrade in order to use your package. Now, if you didn't want the user to have to do that, then obviously you can't use the new pipe, because then your package is not going to work. So that's a decision you have to make. Like you might decide, okay, well, I want to stick with the old pipe because people with older versions of R can still use my package. Does that make sense?
Yes, that makes sense. It's kind of a knowing your audience question in terms of how savvy are they, or how on top of it they are with upgrading their R versions. I know just we don't update as often as we should because nobody likes having to get IT and take their administrator privileges to do it.
Right. Yeah, so but in that situation where your package does depend on a particular version of R, then add this information in here. Add what version it's dependent on, because if you don't, somebody with an older version of R will have no clue why your package is not working for them. And if you put this in there, it's going to be very clear that, hey, it's not going to work without a newer version of R. There's been quite a few changes in the newer versions of R, so I mean, I would tend to, prod people to upgrade to the new 4.x version. Okay, so Peter asked, could we look briefly at the little forecast RD to see what it created? Yes, let's do that. So hop back here. Let's go back. We'll just switch back to the project here. Test package. Switch back over. Okay, it's in the man little forecast. So what did it do? It created the name, created the alias. What this is that sometimes you might want to be able to bring up the help file using a different name than your function name. So like sometimes like you might do help plot and then you get a bunch of different, you get like one, is that an example? Well, let's just say that you can call up your help file in different ways if you want it, and that's what that alias is doing. Title, the usage, and then it adds the arguments. So defining the data, what the in years is, the value, here's the description, and then examples. So is that not something humans would do? Yeah, humans would not look at this. Humans would look at this. They would look at the header and just read this. And then our oxygen, well, actually it's the package building process is reading that RD file, and then it's creating. So I have to say, I didn't load the package because I was switching projects, so I need to reload it. There we go. So now, yeah. So the R package is using that RD file to create this and all your various ways of viewing your documentation. Okay. Oh, okay. Thanks, Ariana. That's so there was a question about a sort of a command control key for you inserting the pipe. Read about that. Okay. Key structure. Okay. Diana asked the ... the colon syntax prevents overwriting of functions. It prevents overwriting. Not exactly prevents overwriting. What it does is it allows you to have functions that have the same name in different packages, and you're specifying exactly which one that you want to use. So you might have functions with the same names in different packages. That's entirely possible. And you're being very explicit about which one you want to use. So I'll also say, just in general, like when I am reading somebody else's code, I end up spending a lot of time trying to figure out which package a function is coming from. And so like if I'm working from somebody's script and they may forget to put a library package call at the top to make sure a library is loaded, because they already have it loaded, so everything works just fine for them. And then they share their script with me and I cannot get it to work. And I have literally no idea what package their functions come from. Like R doesn't know, and I don't have the package loaded, so like I have no idea. And that I can spend just ages trying to figure that out. So when you're sharing code with other people, using that convention of putting the using : especially if it's a package that people don't typically use, you can really help other people, even if you're not writing an R package, just in general, if you're sharing code. Now, if you're using like, the tidyverse things or a ggplot2, something that's really common for people to use, then, you might not do that, or you probably wouldn't do that. But for other things, it's going to be really helpful.